As the size of devices is getting smaller, easy to carry, the devices require low power consumption and battery to supply power to use for a long time. The M2351 series microcontroller provides some power modes. If the microcontroller does not need to work for a long time, you can set low power standby mode to save power and increase battery lifetime. M2351 power mode includes System Startup in normal mode, System Standby in idle mode. Low power power down mode includes Normal power down mode, Fast wake up power down mode, Low leakage power down mode, Ultra low leakage power down mode, Standby power down mode, and Deep power down mode. Different power modes power distribution. System starts up in normal mode. VDD supplies power to digital logic, including HXT, LIRC, I/O, DPD, control and internal voltage regulator. The internal voltage regulator type can be selected as LDO or DC-DC mode. The output voltage level can be selected as 1.2V or 1.26V. The internal voltage regulator supplies power to other digital logic including SPD control, CPU, HIRC, peripherals, flash, SRAM, and so on. AVDD supplies power to analog peripherals. VBAT supplies power to LXT and RTC. System standby in idle mode. Only CPU clock is disabled. It is the fastest mode that system can return to normal mode. When system does not need to work for a long time, you can set low power power down mode. Different power down mode disables different level power. In power down mode, besides CPU clock, HXT, HIRC, and DC-DC are also disabled. LDO is in low power mode. In fast wake-up power down mode, LDO is not in low power mode to save wake-up time, but it consumes more power. In low leakage power down mode, LDO voltage drops down to 0.9V to save power. In ultra-low leakage power down mode, LDO voltage drops down lower to 0.8V to save power, but it takes more wake-up time too. In standby power down mode, some logics and memories are disabled. Only SPD can control SPD wake-up source, and system SRAM bank 0 data can be retained. In deep power down mode, most logics and memories are disabled. Only DPD can control DPD wake-up source. After wake-up, system needs the longest wake-up time to initial again to work normally. Different power modes transition. System starts up in normal mode. The default voltage regulator type is LDO, and output voltage level is power level 0, 1.26V. A lower voltage level power level 1, 1.2V can be selected to save power, but lower CPU operation frequency. Or another low power voltage regulator DC-DC mode can be selected. System can set idle mode at any voltage level and voltage regulator. After wake up, system returns to normal mode. System can set power down mode only in LDO mode at any voltage level. After wake up, system returns to normal mode. If system set standby power down mode or deep power down mode, because most power are disabled, after wake up, system will reset and return to normal mode default state. Voltage level is power level 0, 1.26V. Different power modes comparison. For power consumption, the system starts up in normal mode that consumes the most power. followed by idle mode, and then fast wake up power down mode, normal power down mode, low leakage power down mode, ultra low leakage power down mode, and standby power down mode. The least deep power down mode saves the most power. For wake up time, normal mode is system startup mode, so there is no wake up time. Other power mode, which is more power saving, takes more wake up time to return to normal mode. For data retention, in normal mode and idle mode, all data is retained. In power down mode, SRAM power can be controlled by registers. If user wants to save power, you can disable SRAM power in power down mode, but the data in SRAM are also lost after wake up. In standby power down mode, only system SRAM bank 0 power can be controlled. Other system SRAM bank 1 and peripheral SRAM power are disabled. In deep power down mode, all memory's power are disabled. After wake up, all data are lost and not retained. M2351 provides different power consumption modes. The most power-saving mode takes more wake-up time and causes more data lost. User can select proper power mode to design their application, both low power and high efficiency.